Hey guys, sorry I can't be there today. We're going to be talking about vectors in 3D or vectors in space. I just tried to make it sound more exciting. To be completely honest with you, this is not very exciting. Um, I know sometimes you think like, ooh, 3D, maybe it's going to be cool or difficult or something like that, and it's not. And I thought that I might as well just go ahead and, show you the picture of the Tesla that is it orbiting Earth? I'm not even sure with the kick butt robot mannequin guy in there who's just like chilling. I love it. I love that Elon Musk gets to be like, gets to live out every 8-year-old's dream when they strap a Hot Wheels to a bottle rocket and send it off into the neighborhood. Anyways, so vectors in 3D. Essentially, we're just going to be taking everything we do and adding a third three-dimensional component to it. So, I also want to apologize because I don't have a stylus, so I have to use my finger, and so it's going to take me a little while to write. So let's talk about a point in space. So if I've got a point in space, I can have A, which would be x1, y1, z1. And then I would have another point out in space, that's B, and that's going to be x2, y2, z2. Now, if I want to find the vector that is formed between these two guys, if A is my initial point, and if B is my terminal point, Peanut, will you lay off? Okay. To find this vector, to find our first x component, we're going to take x2 minus x1, just like we did in 2D. y2 minus y1, just like we did in 2D. And then we'll just throw in, z2 minus z1 to take into account that third dimension. So, once we have that vector, we can have it in component form, so where it can have v1, v2, v3. We could have it in column form, so SL kiddos, this is you. Oopsies. So v1, v2, v3 in column form. And if you wanted to do it as a combination of linear unit vectors, that would be v equals whatever value I plus whatever value j, just like before. And then you'd think it would only make sense for the next letter to be k. So I just, add a k onto it there at the end. So, once we have component form, it can be pretty easy to go ahead and find the magnitude. So remember, the magnitude is pretty much the distance between those 2 points. And if you remember, the magnitude in 2D was just the distance formula. So distance and magnitude are still going to be oh God, my notes went away. Come on, notes. Come back, notes. There we go. Okay. Here we go. Magnitude. For some reason, I was having a brain fart and couldn't remember how to spell magnitude. Okay, remember, distance and magnitude are the same thing. So if we're trying to find that, we're going to take x2 minus x1 squared plus y2 minus y1 squared, just like before. But now we're going to add in that third component, so z2 minus z1 squared, and then we'll still take the square root of all of that. So that doesn't change very much. Same thing if you wanted to find the magnitude, but it's already in vector form. You're just going to have v1 squared plus v2 squared plus v3 squared and the square root of that whole thing. All right. So first, let's go ahead and find a couple of these guys. So I'll give us 2 points. Let's find, sorry about this bad writing. I apologize. Find the component form. And the magnitude. Okay, so first guy, we're going to use, oopsies, that's ugly, point A, which is going to be at 9, -4, 1. That's going to be my initial point. And then I'm going to have point B, which is going to be at 6, 2, -7. And that is going to be my terminal point. So if I want to find vector form, component form of this vector, remember I take my terminal point minus my initial point. I had a few people get that confused on their homework, taking initial minus terminal. It's terminal minus initial. So we're going to go through and take 6 minus 9 for our first component. 2 minus -4, so 2 plus 4 for my second component, and -7 minus 1 for my third component. So when I go through and simplify that, I'm going to end up with -3, 6, 8. Ooh, ugly 8. Better 8. All right, so there is component form. All right. And then if I want to find the magnitude, I would just take the square root of all of this stuff squared. -3 squared plus 6 squared plus 8 squared. So we've got 9 plus 36 plus 64 is going to give us 109. So we got the square root of 109 for our magnitude of V right here. Neato. All right. So now let's look at another example. Let's have B be -1, 5, 8. Or point A for be -1, 5, 8. And there we go. Point B, let's have that be 17, 21, 85. Because what the heck and why not? All right, so once again, A is going to be my initial point. B is going to be my terminal point. So to find this vector, I'm going to take terminal point minus initial point. So I've got 17 minus -1, so +1. Second part, I've got 21 minus 5. Then I've got 85 minus 8. So we'll go ahead and simplify that all down to find our vector. And we'll get 18, 16, 77. And then if we want to find the magnitude of V, we're just going to take each part of these, 18, square it, plus 16, square it, plus 77, square it, and take the square root of that whole total. And then when we take whatever 18 squared plus 16 squared plus 77 squared is, we get 509. All right, beautiful. So, let's talk about a few more things that we can do in 3D. Now, I know it's disappointing finding out that 3D is really not all that different, but maybe it can help you out knowing that most things are not going to change. Vector rules are not going to change. I'll show you how to do dot product here in a little bit, but still the pattern is still the same. We're just slapping on an extra thing at the end. So let's go back real quick. Come on, there we go. And talk about finding the midpoint between 2 points in space. So if you remember midpoint from like geometry or something like that, you would have x2 plus x1 or x1 plus x2, it doesn't matter. And since you're trying to find the number that's in the middle of those two, you're trying to find the average. So you have two numbers, add them together, so you have to divide by 2. Then we have the y components, that's y2 plus y1 divided by 2. And then to get that other part, we just have to slap a z in there. So z2 plus z1 divided by 2. So that's how we're going to find the midpoint of those segments. So now that we know that, let's hop back to those examples that we just did and find the midpoint between those 2 points. Okay. So on this guy, if I want to find the midpoint, let me change colors here. Midpoint. All right. So to find my midpoint here, I'm going to take my x terms. So 9 plus 6. Divide that by 2. I'm going to take the y terms of those 2 points. So negative 4 plus 2. Divide that by 2. And then take the z terms. 1 plus negative 7 or 1 minus 7. Divided by 2. So then when we go through and we simplify that down, the midpoint between 9, negative 4, 1 and 6, 2, negative 7 is going to be 15 halves, negative 1, and negative 3. So 15 halves, negative 1, negative 3. Beautiful. So that's how we find our midpoint. So let's find the midpoint on the next one. I would love if you would just pause me, find it, and then like zoom ahead however many seconds it takes and just double check that you're right, because I bet you will be. It's not too terrible. So I've got 17 plus negative 1 for my x components. I've got 21 plus 5 for my y components divided by 2. And I've got 8 plus 85. for my my z components. Divide that by 2. Just to point out real quick, make sure that you're using parentheses on this because this is a coordinate out in space. And here in a little bit, I'll show you how to graph it, but it is a coordinate. So make sure you're using parentheses and not those kind of triangle brackets on there. All right. Anyways, here we go. So I got 17 minus 1, 16 divided by 2 is 8. 21 plus 5 is 26, divided by 2 is 13. 8 plus 85 is 93, which is odd, so I'm just going to leave it over 2. Beautiful. And there's my midpoint. So, if we can find magnitude, can we find a unit vector? Abso-freaking-lutely. So let's have a conversation about how we find the unit vector. Now, I think some of you guys forgot how to find the unit vector back before we took that quiz, so this is something you might want to tuck back in your brain. So for anything, 2D, 3D, you're going to have 1 over the magnitude of the vector times the vector. So let's go through and find the unit vector for those two vectors that we found a little bit earlier. Does that sound like fun? Yeah, I didn't think so. But hey, we can do that anyways. Here we go. All right, so we are rocking this vector right here. And the good news is we've already found its magnitude. So we don't have to go through and do a whole bunch of extra work. So down here in green, I will do my unit vector. So remember, I want to have 1 over the magnitude. So I'm going to have 1 over the square root of 109 times the vector. And my vector is -3, 6, -8. And then you just take this scalar out front and distribute that sucker on through. Or scalar, if you prefer. So we've got -3 over the square root of 109. And if you enjoy rationalizing your denominators, you go right ahead. I am not going to stop you. But I'm not, I don't feel like it. Then we'll also have 6 over the square root of 109 for my y component. And -8 over the square root of 109 for my z component. So that right there, if you were to go through and find the magnitude of that guy, that would be, the magnitude would be 1. So that is your unit vector. Ain't it a beaut? Okay, so let's find the unit vector on the next one. So once again, hard work is already done because we've got our vector. And we've got our magnitude already. So, if we want to find our unit vector, I'm going to take 1 over my magnitude. So, the square root of 6,509. Times my vector, which is 18, 16, 77. And then we'll take that scalar and we'll distribute it out. So our unit vector here, the x component is going to be 18 over the square root of 6,509. The y component is going to be 16 over the square root of 6,509. And my z component is going to be 77 divided by the square root of 6,509. So if you decide to, if you go through and find the magnitude of that vector, I guarantee you it will be 1, I think, probably, if I didn't make any mistakes. But, yeah, unit vectors work the exact same way. So, a few more things about 3D. Let's have a fun little conversation about how we do dot product. In 3D. So remember, if you had like vector v, which was going to be v1, v2, v3, and you have vector w, which is going to be w1, w2, w3. If you wanted to take v dot w, you are going to take, whoopsies, v1 times w1 plus v2 times w2, just like you do for the regular dot product, but now you just slap in that third part. So v3 times w3, gonna add that sucker onto the end. So if we want to find the dot product between two vectors, so maybe we want to find the dot product between, let's use 2, 6, and negative 3, and we'll dot that with 7, negative 2, and 0. So if we want to take v dot w, we will take 2 times 7 plus 6 times negative 2 plus negative 3 times 0. So when we go through and we add all these up, let's see, we have 14 plus negative 12 plus 0 gives me 2. So their dot product will be 2. I think that pretty much makes sense. If you'd like to see another example sometime, let me know. But I think you can get the idea from that. All right, now I had a realization a few days ago that was I have been graphing incorrectly in 3D for years. I had been using a completely different system than what the rest of the world was using, and I have screwed up one generation of students. I will not do that to you. So here's how you are going to graph in 3D, and I will show you how to draw your graphs here in a second. Now, what you want to do is you're going to leave what I like to call a slug trail. You are going to start at the origin, and you are going to trace your way around to what you're doing. Now, when I go through and graph these, it is not going to look right. That's because I'm trying to show something that is 3-dimensional in 2 dimensions. It doesn't look right. It's fine. If I can follow your slug trail, you'll be all right. Okay, so the first thing you want to do is you want to plot on the x-axis. And your x-axis is going to be going a totally different direction, so it's going to be a little trippy at first. Then what you're going to do is you're going to show your little slug trail parallel to the y-axis. So that way you can go in whichever direction you need to for the y-axis. Then, from there, you are going to show your little slug trail parallel to the z-axis. So it'll be a little strange to see how that looks. So here, we are going to... first let me show you how you're going to draw your, what are they called? Coordinate planes here. Now, actually, going straight up in the air right here is going to be your z-axis. So going up and down vertically is no longer your y-axis, it is your z-axis. And on the other side, where it's going to go negative, I usually make a dotted line, so that way it's a little bit easier to tell. Now think of it as like kind of a corner of a room. So coming out this direction right here, this is going to be my x-axis. And in the opposite direction, is going to be the negative direction of x. Not quite perfect, but whatever. And then, like I said, like it's coming out of like it's making a corner of a room. Right here is going to be your y-axis. And going in the opposite direction is going to be where y is negative. Okay, I'm going to take this thing and copy it, because that took me forever. Copy. Paste. I wish they had copy paste for like actual notebooks. That'd be rad. Alright, so the first one that we're going to do is we are going to graph the point 9, -4, 1. And then on the, on the other point, or on the other graph, we're going to graph the point 6 to -7. Okay, so let's graph out this point A first. So I'm going to start at the origin. Then I'm going to go 9 units on the x-axis. Oops, that's not very straight. And let's just go ahead and say that right there is 9 units. Now I have to go backwards 4 units, or -4 on the y-axis. So actually, let me move that 9 over. I'm going to put that over here. So I'm going to put -4 on the y-axis. So I'm going to need to go in the direction where it's dotted. And I'm going to go parallel to that axis that I drew. So it's kind of like some perspective drawing, only I suck at drawing. So you kind of have to figure it out. So then we'll say that right here, maybe 1, 2, 3, 4, maybe that matches up with it going back 4, -4. Okay. And then from that point, I'm going up 1. So then I will make some sort of move parallel to my z-axis from that point. That looks like it might be about 1 unit. Now, that looks weird. It doesn't really look like what's going on, but you can kind of tell from drawing those little marks where you're going to end up. So that's how we grade it. And honestly, if you ever see something graphed in space, you should see that little slug trail that's left right there. Okay, so let's do the same thing over here. So first thing, 6 units positive on the x-axis. Actually, let me do this in a brighter color. Let's go with a lighter green. Alright, so I start at the origin. I go positive, let's call this 6 units on the x-axis. Then I'm going to go positive 2 units on the y-axis. So I am going to go what looks to be maybe about-ish 2 units parallel to that y-axis. So this is 2 units right there. And that's where we kind of stop at that point. Then I have to go down 7. So parallel to that z-axis, I'm going to go straight down what seems like would make sense for 7 units. So maybe we can say we went down 7 here. And this is point B right there. So I know it looks kind of strange. You won't have to graph any on your homework. I just wanted you to know what it looked like. So your homework is on Schoology. I'll see you tomorrow. I'm going to give you your review for your test. We'll go over your questions on the review on the block day of next week, which will be Thursday. So I guess I won't. Oh, well, I'll see you tomorrow. Everything will be fine. And then we'll take our test next Friday. So, have a fantastic day. I will see you later.